Hello everyone, I am Abhishek Datta and you are watching my YouTube channel Mathematics Made Easy. I am here today to discuss about the concept of infinity. You must be all familiar with the term infinity. It is frequently used in different branches of mathematics, particularly in the study of calculus. From the ancient time, infinity has always been among one of the most interesting as well as the most challenging topics in mathematics. There are many parallel concepts, parallel ideas about infinity. Different mathematicians in different time era has expressed their views regarding infinity, but none has been able to arrive at a particular conclusion till today. Even today's modern science has a very limited idea about it. So, what is infinity in true sense? Naturally, the first question that arises in mind, that is infinity a number? And if so, if it is a number, then what is its magnitude? What value we can assign to infinity? In fact, people commonly consider infinity to be a very large positive number, however large may be, which may be made larger than any pre-assigned natural number. Natural number, as you all know, that is positive integers. Any positive integer is also termed as a natural number or counting numbers. So commonly, people consider infinity to be a very large number which can be made even larger than any pre-assigned positive integer. So practically, people associate the concept of magnitude to infinity, which is actually not true. Which is actually not true. So if infinity is not a number, then what is it? Truly speaking, till today, we don't have a proper definition for infinity. There are many other concepts in mathematics also that till date we don't have a proper definition. Likewise, a point. We cannot define a point in true sense. We cannot even define a line in true sense. Probability, another very important, interesting concept of mathematics, probability, has also no true definition today. Set theories have no true definition today. So likewise, infinity also is considered as a concept, within quote concept. We consider infinity as a concept, as an idea. It is not a number. It's a concept. Anything which is boundless, anything that is limitless, anything that is endless can be compared to infinity. So infinity is the idea of endlessness, or having no bounds, having no limits, but it certainly is not a number. Now, let me illustrate this in another point of view, considering the numbers themselves, that why we cannot consider infinity, or in fact why we cannot attach the concept of magnitude to infinity. To discuss that, let me consider two numbers, say 0 and 1, on the number line. You all must be familiar with the number line, the real number line. That is the line on which we can plot all those real numbers. So if I consider the two real numbers 0 and 1 on the number line, we all know that there are endless number of values, endless number of points between these two, 0 and 1. Endless number of points. Say 0.1, 0.001, 0.0001. So as I go on increasing 0 between the decimal point and 1, each time a new number arises. Likewise, 0.11, 0.111, 0.111, and you go on this process, go on continuing adding 1. So every time a new number will arise. So likewise, this counting process will never end. We can never reach from 0 to 1 by this counting method, by this counting process. So you see, there are endless number of values, endless number of real values between 0 and 1. That is infinite number of values between 0 and 1. Now if I consider another 2 points, say 0 and 1000. Let us now consider another 2 points, 0 and 1000. So similarly, there are also infinitely many values between 0 and 1000. Likewise, if you start the counting process, it will never end. So see carefully that we have two scales, one 0 to 1, the second one is 0 to 1000. The first one is very small in comparison to the second, that is 1 by 1000 part of the second, if you consider them lengthwise. But both include infinite number of points within them. Even if you consider the points 0 and 0.1, 0 and 0.1. So between them also, we have infinitely number of real values. You must have studied all these things in calculus, that the set of real numbers is dense, because you go on increasing 0 between the decimal value and the 1 value, every time you will get a new number. So even between 0 and 0.1, there are endless number of values. That is infinite number of values. So the concept of infinity applies in all the three cases. For the pair of numbers 0 and 0.1, for the pair 0 and 1, as well as for the pair 0 and 1000. All of them have different magnitudes. The first one is very negligible in length, 0.1 units. The second one is only 1 unit in length, and the third one is 1000 units in length. But all of them includes infinite number of points. So from this illustration, it is very much clear that the concept of magnitude does not hold with infinity, because infinity can exist in a large scale between two vast points on a number line, or we may have the same concept even between a very small fragmented portion also. So infinity cannot be considered as a number. We cannot attach any magnitudinal value or a magnitudinal concept to infinity. So what is this? It is just a concept. It is a concept of endlessness. It is a concept of boundlessness. It is a concept of no limits. Now, many people consider infinity to be uncountable. They consider whatever set is uncountable, that is infinite, and whatever set is countable, that is finite. But actually it is not so. Uncountable does not necessarily mean infinite, or countable does not necessarily mean finite. Now, by a countable set, what we mean by a countable set? If I say that a set is countable, by this we mean that we can count the individual members of the set one by one. We can count them. We can assign every member a positional value. Say first member, second member, third member, fourth member, and so on. Let us consider the set of integers, set of positive integers. Say. That is the set of natural numbers, the set of positive integers starting from 1. 1, 2, 3, 4, 5, 6, and it goes on and on and on. It is endless. You know, there are endless number of positive integers. So the set is clearly infinite. The set of positive integers is clearly infinite. But it is also countable. Why? Because we can clearly count the members. It doesn't matter whether it has a finite number of members or infinite number of members. If you can count the members, that is, if we can assign a positional value to each and every member, first position, second position, third position, that means they are countable. We are able to count them. So this is the example of an infinite set which is countable. Whereas, if you consider the interval, close interval 1 to 2, by a close interval we mean set of all values, set of all real numbers lying between 1 to 2, including the extremities 1 and 2. So this set also have infinite number of values, as we discussed earlier. But clearly this set is not countable. Why? Because you cannot distinguish between any two real numbers in a closed interval. That is, you cannot say the real number which just lies after 1. If you say it is 1.01, so if I impose an extra 0, we get a number before that. Then you impose another extra 0, 1.001, we get a number even before that. So we cannot distinguish between any two real numbers in such a closed interval. So here we have a set which has infinite number of points, but the members are not countable. We cannot assign the concept of countability with such a set. Whereas in the set of integers, we also have infinite members, but we can assign a positional value to each and every member. That is, we can associate a bijective mapping, those who know the idea of mapping, a 1-1 onto correspondence. We can associate a 1-1 onto correspondence, that is a counting technique in the set of natural numbers. So this is another wrong concept which people commonly bear with them, that any set which is uncountable is infinite, and any set which is countable is finite. It is actually not so. Both sets can be infinite. May it be countable or it is uncountable. In language of mathematics, we call it enumerably infinite and non-enumerably infinite. Enumerably infinite, that is countably infinite, and denumerably or non-enumerably infinite, that is uncountably infinite. So basically infinity is a concept. It is a concept of endlessness. This cannot be associated with any magnitudinal concept or any countable approach. So in this video we cover up to this point only, and we shall continue some more discussion about infinity in our next video, because I want to keep the videos short in length. It will be easier for you also to grasp the concept then. So we shall be continuing in our next video about some more thorough concepts of infinity, about addition of infinite sets, about subtraction of infinity from infinity, whether we can subtract infinity from infinity, whether we can add infinity to infinity, whether infinity can be multiplied with infinity, or whether infinity can be divided by infinity. That is the all four fundamental operations of arithmetic: the addition, subtraction, multiplication and division, whether they can be performed with the concept infinity. And also we shall discuss the operations of real numbers, finite real numbers with infinity. I hope this discussion is helpful to you all. If you have any questions or any queries, you can post them in the comment section and I will try my best to answer them. Till then, have a good day and we shall meet soon in the next video. Thank you.